In this podcast episode, Geoffrey Drumm shares his groundbreaking research on the true function of ancient pyramids and megalithic structures around the world, with a heavy focus on the Egyptian pyramids. Drumm proposes these structures were part of an integrated, industrial-scale chemical manufacturing complex driven by natural earth energies such as toric currents and lightning. The discussion spans the detailed chemical processes inside each Egyptian pyramid, the connection to atmospheric phenomena, archaeological findings, comparisons with global megalithic sites, and implications for ancient civilizations' technological sophistication. Drumm opens by describing the striking ammonia-like smell inside the Red Pyramid, explaining that it is not caused by bats as popularly thought, but by pure chemical ammonia resulting from internal chemical reactions. Chemical analysis and staining inside the Red Pyramid confirm this, demonstrating active industrial chemical processes rather than natural contamination. This sets the stage for understanding the pyramids not as tombs, but as chemical reactors producing valuable compounds. At the heart of Drumm's theory is the idea that the Egyptian pyramids formed a highly advanced industrial complex for chemical manufacturing and metallurgy. Beginning with the Step Pyramid, which extracted methane from subsurface bedrock deposits, the process evolved through the Red Pyramid's conversion of methane into aqueous ammonia. The Bent Pyramid further processed this into urea fertilizer. On the Giza Plateau, two pyramids manufactured key industrial acids. The Great Pyramid produced sulfuric acid, while the Central Pyramid made hydrochloric acid. The final pyramid likely produced a basic solution to neutralize these acids. Throughout, the end products mainly served agricultural fertilizer production and metallurgical activities. The power behind these operations came from the planet itself by harnessing toric currents, natural earth electric currents, and lightning. Drumm emphasizes that ancient builders exploited subterranean conductive features such as groundwater and mineral deposits to channel these currents, thereby intensifying their electrical processes. He compares this ancient civilization's technological prowess to that of a Kardashev Type 1 civilization, capable of harnessing all planetary power and resources. He suggests the ancients were potentially more advanced than modern humans, who are still only fractionally along this path. Drumm proposes that this advanced knowledge evolved over millennia following catastrophic climate events at the end of the last ice age. Starting with stone circles and passage chamber reactors around 10,000 BC, these structures progressively evolved into the Egyptian pyramids over 2,000 to 2,500 years during the Saharan humid period. He also addresses striking global parallels by pointing to similar ancient structures in Japan, Mesoamerica, and the British Isles. The hypothesis suggests that intercontinental travel, or a common point of origin, allowed widespread dissemination of this ancient technology and religious symbolic systems grounded in chemistry and earth sciences. One of the remarkable insights Drumm highlights is the intentional utilization of black, white, and red stones in pyramid complexes, mirroring the mythological color scheme of Atlantis. Black basalt was used for heat storage, white limestone for electrical field storage due to its dielectric properties, and red granite for ultrasound generation, critical to chemical reactions. This color coding reflected a detailed understanding of material properties and functional integration of these stones within the pyramid's chemical manufacturing processes. Drumm explains the critical role of toric currents, subterranean electrical flows influenced by natural water conductivity and mineral wealth, in charging these ancient structures. They serve as precursors to lightning strikes that provided immense electrical input for reactions. Fulgarites, fossilized evidence of lightning strikes, have been discovered throughout the Giza Plateau, embedded within iron-rich veins that act as electrical wiring networks between pyramid complexes. These findings solidify the connection between natural electrical phenomena and pyramid function. Expanding beyond Egypt, the podcast reveals how ancient stone circles in places like Aberystwyth, Abury, Wiltshire, and Japan functioned as lightning attractions that generated atmospheric fertilization via nitrate production during lightning events. These complexes also funneled toric currents and induced electrical charges that served as lightning targets. The White Horse Hill figures carved into chalk landscapes across Wiltshire are interpreted as deliberate thunderstorm generators used to manipulate weather and enhance agriculture, another hallmark of advanced control of natural forces. The Sarapium, an enigmatic Egyptian structure, is hypothesized as an ultrasonic reactor breaking down water into hydrogen and oxygen using induced electric fields in red granite transducers. Here, nature's electricity, channeled through lightning and toric currents, creates ultrasound vibrations that dissociate water molecules. The collected hydrogen and oxygen feed subsequent chemical processes in the Egyptian pyramid complex, especially ammonia synthesis in the Red Pyramid and acid production in others. Drumm draws a direct parallel between the Haber-Bosch process, modern industrial ammonia synthesis, and the chemical engineering seemingly achieved inside the Red Pyramid centuries prior. By manipulating temperature and pressure in meticulously constructed internal chambers and utilizing natural catalysts like nickel and strontium found in the stone staining, the pyramid functioned as a massive steam reformer, converting methane into ammonia. Mathematical modeling predicts pressures reaching 40 atmospheres and temperatures around 500 degrees Celsius, optimal for these chemical reactions, all contained by the pyramid's massive stone body and driven by terrestrial electrical phenomena. The pyramids were linked by the vast subterranean network of tunnels and chambers, reportedly extending kilometers between complex sites. These tunnels facilitated the transport of gases such as methane, ammonia, hydrogen, and other chemicals between pyramids, confirming they operated as interconnected units of one enormous industrial chemical operation. Reports of people who have traversed these tunnels, such as the father of Yusef Awan, confirm their existence. The chemicals produced had diverse uses beyond fertilizers. Ammonia assisted not only in agriculture but also in leach mining copper and in processing crude oil, aligning intriguingly with modern petrochemical applications within 10 kilometers of the Red Pyramid today. Some speculate about their use in rocket fuels, though Drumm emphasizes pragmatic industrial and agricultural uses. The bent pyramid produced solid fertilizer compounds, likely from ammonia and carbon dioxide byproducts. The Great and Central Pyramids manufactured sulfuric and hydrochloric acids for metallurgy and possibly for purifying gold and silver ores via mercury amalgamation, as evidenced by discoveries of liquid mercury tunnels under the Teotihuacan complex in Mesoamerica. Drumm dispels myths about primitive technology, arguing ancient Egyptians mastered iron and possibly steel, as an iron plate was discovered inside the Great Pyramid, challenging claims that iron was unknown before later periods. Stone cutting was achieved through metal tools enhanced with corundum abrasives capable of sawing granite with extreme precision. The symmetry and intricacy of statues and obelisks suggests sophisticated tool use supported by knowledge of materials and measurements. One of the most compelling proofs comes from a 140 scale plexiglass model of the Red Pyramid's internal reaction chambers. Designed and built over a year by a dedicated supporter, this model demonstrated the fluid dynamics of water and gas in the pyramid reaction sequence, including compression and pressure generation. The model survived pressure increases equivalent to 40 atmospheres at scale before catastrophic failure, confirming the architectural necessity of the massive pyramid body to contain extreme internal pressures and stabilize chemical reactions. Drumm connects the practical chemical functions of the pyramids with their enduring mythological resonances. The Egyptian god Ammon, source of the word ammonia, symbolizes fertility and fertilizer, highlighting the divine recognition of nitrogen compounds' importance. The legacy of ancient Egyptian chemical knowledge traces through alchemy into medieval Europe and modern chemistry, a continuum of specialized knowledge passed through secret societies and encoded texts. Similar mythological profiles emerge globally, from Aztec rain gods to Japanese thunderstorm and lightning deities, symbolizing the universal awareness of the link between atmospheric electricity and agriculture. Beyond Egypt, Drumm explores the stone circles and pyramids of Britain, Japan, and Mesoamerica, functioning under the same principles of natural electricity manipulation, lightning attraction, chemical manufacturing, and weather modification. The cumulonimbus white horse thunderstorm generators in Wiltshire and similar landscape features at Teotihuacan and elsewhere are part of this global system. Stone and standing stones acted as lightning rods with electromagnetic step-down voltage transformers, such as Sphinx avenues, connected complexes like Karnak and Luxor, distributing high-voltage electric currents safely. Drumm advances the hypothesis that the intense thunderstorms and rainstorms required to transform the Sahara from a lush, fertile region to desert correspond to and may have been augmented by these ancient thunderstorm generators. The operation of these chemical and electrical complexes aligns with the Saharan humid period from roughly 8500 BC to 5300 BC, suggesting a form of early terraforming, transforming arid landscapes into productive agricultural land through controlled manipulation of atmospheric phenomena and fertilizer production. The research is gaining traction in some academic and engineering circles, with articles published by PhDs in physics and engineering supporting Drumm's hypotheses regarding temperature and pressure regulation in pyramids and the natural electrical power source. Industry engineers familiar with current chemical and power plant operations find historical precedent for the proposed processes in the ancient world. Yet Drumm acknowledges that his rational, practical, and nature-based theory sits outside the polarized mainstream alternatives focused on tombs or extraterrestrial conspiracy, finding itself in a relatively neglected middle ground. Addressing common skepticism about how these enormous structures were built and stones transported, Drumm asserts that the core limestone blocks were quarried locally on the Giza Plateau, disproving myths of massive stone transport over hundreds of miles. Granite casing stones came from quarries in Aswan and floated down the Nile on large boats, facilitated by the river's flow from south to north. Primitive but effective pulley and gantry crane-like technologies analogous to Roman cranes likely enabled lifting and placement of heavy stones. The motivations for such enormous architectural investments lay in the valuable industrial applications and lasting legacy, not simply ceremonial or funerary purposes. Drumm points to megalithic constructions worldwide, from Japan's Coromant Pyramid, which exhibits internal granite chambers and geothermal gas seepages linked to flame emissions, to the stunning rock-cut temples of India, as part of a global pattern of utilizing natural geological and electrical phenomena in construction and operation. He highlights similar chemical, electrical, and acoustic principles at work, and theorizes intercontinental trade and knowledge exchange forged these parallels. Throughout, long-standing rituals and legends encoded practical insights about managing earth energies for survival and prosperity.